Hello there reason people, PoohBear here and welcome to my channel, and today we're going to actually be building ourselves a counter. We want to have something where we can count up, we want something where we can count down. Now your most basic form of counter you can actually get in Reason if you're looking at something over time would be an LFO, simple as that. Something which will obviously, we've got a ramp up, which is obviously going from a 0 volt going upwards, and we've got a ramp down, which will be starting more likely at 1 volt and then ramping down. And obviously, if you want something to go up and down, you've got yourself a triangle. So you've got yourself some basic LFOs, and obviously you could play around with the rates so they go up a lot slower and then speed them up at the end or whatever. But we want something where we're going to say to it, you're going to move up by a set amount, and it's going to be a random amount of time before we're going to actually ask you to move up another set of another set amount. So it's going to be a variable amount of time. So LFOs don't really fit into that mold. I'm going to grab myself Hamu, and I'm purely using the Hamu because it's got a little momentary button. I'm also going to grab myself, oh, I tell you what, let me put a scope in there, because then I can wire up the momentary button to the scope, and if I use that button down on the floor, I can quickly switch to the back. So now, when I hit this, he says, and when you add these mod panels in, you've got to remember to take the hold out turned off. You can see as I hold the button down, we can either hold it down, it goes, and if I just quickly flick it, it goes. And by the way, the momentary button is when the mouse down, it's on. I let go of my mouse, it turns it off. Whereas obviously a toggle, I have to click and click again. That's just a mouse on, mouse off to actually see what's going on. So the next thing I'm going to do is I'm going to grab myself a dual CV source, because at the moment, and if we flip round to the back and I take this output and put this output into this input, you're going to see when I click on this button, it jumps up to, that's my 1 volt. And that's what it's going to output, which is no good, because 1 volt, believe it or not, the speed things are going to be working. We're going to start hitting limits incredibly quickly. So what I'm going to do is I want to scale this right down. Now, one of the nice features of the dual CV source is if I was to say I want to scale this right down to something like 0001, I'm going to hold my shift key down, and obviously that puts me in fine mode, and I always have my mouse set to very precise. Well, the smallest I can actually do it via using the shift in that is 0016, which is obviously no good. But a lovely feature on here is I can actually click the screen, and it's now showing me what this is set to. And now I'm going to just drag down with the mouse, and I can set this now to 0001 if I want. Obviously, I can set this to any figure. I can obviously say I'm going to have that up to 201, or I might want that on a 1. So this is, and as you can see with the bigger numbers, you can see this knob move. And if I hover my mouse over here, you can actually again see this is 0001. So it's brilliant for setting very, very specific values and very, very small values, which you can't get when you're just moving your mouse. So let's not get too sidetracked, but it is an important feature of the dual CV source, I think. I'm going to grab myself a spider, and actually I'm going to grab myself another dual CV source, I think. And what I'm going to do is I'm going to take the merge out into the split. I'm going to take a signal out of the split. In fact, I should be able to zoom in here, can't I? Yeah. And I'm going to put that back into the merge in. So I've created myself a really tight loop. Now, thankfully, Reason will break off from this loop, and we can actually see that working. And I'm going to take a feed from that split and put it into this monitor so we can actually see what's going on. And at the moment, it's just throwing around 0 volts, and that's what's whizzing through the system. I'm now going to take a feed from up the top and inject that into the merge side. So we're going to be injecting it. That's what effectively we're going to be doing. So when I click my momentary button, I'm going to open up, well, I'm going to feed it through, I'm going to scale it down, and I'm going to add it into this counter. So if I was to hold it down for a long time, you can see we're whizzing up. If I was just to flip it, we've still jumped up some bigger numbers, which isn't what we're after, because we want this to be nice and smooth. We want to have control of exactly how much we're going up by. And there's another lovely feature of the dual CV source, and it has what's called a latching mode. And what this latching mode is really doing is it's looking for a change in the value at the top. Well, with our momentary button, we're going from a 0 to a full volt, and so it's going to say, hey, you've actually triggered, and we can actually have a look at that. So if I was to, right, so I'm thinking about doing other things here, so I'm going to keep it simple to start with. I'm going to take this feed, and obviously as soon as I've unplugged it, this is now become a constant value, so you can see this is going to count up, and eventually this will actually break. And the reason this will break, because there is a limit on the CV merge splitter of 1000 volts going into the merge side. I'm going to take this feed and put it into this little padlock here, because that's my latch. I'm going to come over here and turn this to latch, take that feed out and put it over here. You can see we instantly stop. I'm just going to unplug the splitter and plug it back in, so we've reset the counter. And now this time, when I hit my momentary button, I'm going to click it and hold it down. We've gone up by 1. I'm going to click it very quickly. We go up 1. So it doesn't matter if I click it quick or I hold it down, we're only going up by 1 value. Brilliant, we've actually built ourselves a counter. That's absolutely fantastic. And what I'm going to do now is I'm going to take this dual CV source, I'm going to make a copy of it. I don't have to make a copy of it, but I'm going to make myself a copy of it. And this time I'm going to take this momentary button, and you'll be able to see it. So that's going to be in blue. I'm going to put that into this padlock here. We don't have to go via compare, by the way. We can obviously come straight into here. So we've now got a very, very similar setup, but the big difference, what I'm going to do with this one is I'm going to pull this down to 0, so it's now a -1. So now if we click on this one, we should go, oh, I haven't wired that into, whoops, sorry, that's my Zoom program going whizzing off. I need to take that feed and put that into the merge as well. Sorry about that. So let me flip back to the round and zoom out. So this time it should count down, and this one will count up. Hey, so we've built ourselves a very simple counter where we can have control of things going up and down. And sorry, so the blue, that's what you're actually seeing, is the go down, and the red is go up. Fantastic, a nice simple counter. But let's take this a few extra steps. Let's actually take it to a step where we want to say, hey, I want to work very similar to, say, to a ramp. I want to have a value, and I either want to count up to that value, and once I hit it, I'm going to reset back to the beginning, and then I'm going to count up and reset back to the beginning. Or I might want to count down, and once I get to a value, I need to reset back up so I can start counting down. If you think about it, as I say, this is part of my INC project, so I want it to count up by at least 53 different phrases. So that's something I'd be looking at. And I'm also going to be having a countdown part of it, because I'm going to be looking at the lengths of my phrases and saying I've got to count down, and once I've counted down, I can then tell it to count up my other counter to move my phrase to my next phrase. So that's the sort of thing I'm thinking about, and let's have a look at how we can actually do that. So to do that, we're going to need our good old friend, the AB switch. Let's see what we've got. There we go. Let's grab the AB switch in here. And in fact, what I'm actually going to do, I'm going to remove this dual CV source just to clean it up. And in fact, I just got to do something over on my other screen. So hang on, so where we are. Now we're going to do two things with this CV source. The first thing we're going to do is I'm just going to take a split out of this merge, and I'm going to put it into the A. I'm going to take that output and put it into, so I'll put it into the B, the output into the A. And then what I'm going to do is, for the moment, I'm just going to take this output and put it into that A, because this is going to have 0 volts going down there. So we've got ourselves 0 volts. And what that would actually allow us to do is, if I'm clicking my switch, he says, let's put this onto B, click my switch, we can see this is counting up. And then obviously if I was to push this to A, we've now re-zeroed it. So I don't have to keep going to the back of the spider to unplug it and to plug it back in again. Now, so this is on plus. Let's put this to minus, say for example. And I want to go from a value, I don't know, we'll think of some value, and we want to come down. So what I need to do is, when I get this to A, and that's I'm going to take this, I'm going to set this to, let's say set this to something like 14, I don't know. There we go, let's say 14. And I'm going to take that value out, and I'm now going to put that into A. So when I hit the reset, we're going to reset to 14, and then obviously as I come down, that comes down, but it's still going to go past 0, you see. And then when I hit that, it's going to come backs and forwards. But what we can do is, I can take another feed out of the splitter. So now when it goes to a minus figure, it's going to automatically flip the AB switch into A, which was then going to take 14. 14 will go into the loop. Because 14 is now a positive number, it'll flip this back to B. So effectively, we're going to go round and we're going to keep counting. Which is, now we've got ourselves a counter coming down. However, if you look very, very careful, you can see there's a little glitch where it's going to go to a -1 whilst it whizzes round its loop before it jumps back to the 14. Now, in a lot of circumstances, that's not going to be an issue, but in obviously other circumstances, that is actually quite an issue. So I'm just going to grab this CV analyzer, and the reason I'm going to grab the CV analyzer is, if I just flip again around to the back, and I'm just going to, whoops, don't you hate that? I'm just going to put that into the CV in. And the reason I'm doing that and put this onto raw is because this has a min and a max on it. So as I come down, it's showing the minimum value, and we want it to stay on 0. We don't want it to go down any further, but obviously when I hit my button once more, so I'm going to hit it now, you can see it's gone to -0.001, which is something what we don't want. So is there anything we can actually do to stop that? Well, yeah, there is actually. It all comes down to how we wire this up together. At the moment, I'm splitting it between the merge and the split here. So let's just unconnect them two. I'm going to wire them back up again. So it's back to the way it was. And what I'm going to do now is I'm going to remove, I'm just working out my loop round. So I'm going to take this one over to this side. I'm going to take this split out and put it into this switch. I'm going to take the output and put it into the B side. And I also need to push this over to this side as well, he says, because now the switch should be switching before the signal goes through. That should work, he says, in theory. So if I reset this, oh, am I happen to be on 0 already? What's gonna, hey, so there we go. Let me reset this one as well, so you can start seeing this countdown. It's going to get to its 0. And remember, before it went to -10, and it hasn't. So yay, we've got ourselves everything the right way round now. So let's just quickly zoom in on what we actually are doing here. So obviously we've got our signal coming through, it's going into this split. We're then taking the feed at this particular point to try and affect our A-B switch. We then also at the same time are taking a feed in, which is then coming out, and then we're tapping that so we can see the result, and we're pushing that back into our loop. So it's just this subtle delay here that it's receiving its signal before it's decided to send the output to be able to switch to A to get the new value to send it to the output. So this is like a real sort of timing kind of, I don't want to use the word issue, but this is a real timing, yeah, it's a timing issue what we are looking at. And you may find that if you're working on bigger and bigger projects and if you've got different buffer sizes, this may not work for you as a solution. So the way to get around this would be on this B, which should be taking its, oh look, even I'm getting myself confused now. This B should be coming from over this side. Ah, okay. I'd have said the B should have really gone over to this. No, I've got to have the B in this side, don't I? Yes, I'm going absolutely mad. What I'm thinking is, if this was we are still getting on a subtle timing issue, what you should be able to do is to put a sloth in between the two. So this will go into the sloth, which will delay the CV signal, get into this input, which should theoretically give this more time to definitely switch over to the A to push the A out. Yeah, that's what I was thinking. Sorry. Yep. And obviously this will also work if we're doing a positive number and all the rest of it. So it's just something to just think about. As I say, it's the latch which is doing the real kind of work for us to allow us to just send out, and this just sends out a simple little trigger. That trigger is obviously triggering. We're sending a value into our merge. The merge is obviously going through, and it works. It works really well. So I suppose the next stage is to actually see this in a working solution. So let's actually go and see a working solution. So here's a working solution. You should be able to recognize this bit up the top here. That's what we've been looking at. It's exactly the same over here, but I've got actually obviously a lot more stuff going on. This is my counter up, and whereas, as I say, I need, because this is part of my ENC project now, I'm counting up to 54. I've actually already scaled it. So at this point here, rather than going up 0.00001, I'm actually scaling it by 80. If you remember, if I divide 1 volt by 128, it's going to come out at 0.00781, blah, 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 blah. But I can round that up because I'm going to be changing an integer number over here, even though it's not a real integer number, they're all CV, but we see it as an integer number, so I want to be able to change the number over here. And that will allow me to do that scaling, and we'll see that working in a second. This would be my start value, so it'd be a simple case of 54 times by 0.008 will give me 4320, which is fine. So that's what I'm injecting in when I hit my reset. And obviously this is the out value as well. So it should, as you probably did see, this would be equivalent of 54. There's my 54. By the way, this is because we're changing this in the CV world, the values you see here are not real. This will have to be read for you to know you're actually looking at the right thing. So what I've done in this little setup is I've obviously duplicated it. So 54, and I'm changing this via the combinator, so it's really changing it and not via CV. So I can actually see what signals I'm actually outputting. What I'm more interested in is the length. I've actually added a length So if you didn't see the previous video, you wouldn't have a clue what I'm talking about. But I've changed my patterns now. Originally my patterns were going up as pattern 1, 2, 3, 4, 5, 6, 7, 8. I've now actually changed them into the CV, the equivalent of the CV value, so I don't have to, I had another dual CV converter, so I've got rid of that already. I've got these patterns, which again, I'm actually, that's coming into here. I'll talk about that in a second actually. So this is the one to keep an eye on if I want to have a look at things. I've had to use the slope already because I've got some timing issues going on. I haven't really configured this right down so to tighten the timing right up. I've got it quite loose at the moment, which is fine because it works. So yeah, so you don't have to have, as I say, little numbers of 1, 2, 3, 4, 5. You can see I'm jumping in 0.008s, and that works for this particular system. So what's actually happening is I'm taking my length is actually coming into here. Then I've got this going via the slope, which will work out, do I need to switch it so it's doing the reset for me, and I had to have it waiting because I needed my signal to come in, then I needed to reset to make sure my signal goes through to reset the counter, and this counter here is coming, as you can see, it's minus in 0.0079 of the actual signal, and that's being controlled by an LFO up here. This is not needed, so this can actually come out. This was more of an experiment. I don't want to go too sidetracked, but this kind of, what I've got set up here is very simple. This is going into A, and this is like going into B, which would be equivalent of a 0 and a 1. What that will allow me to do is, okay, I've got a square, and that's exactly what a square really is doing. It's jumping, you know, it's a square. But I could actually have a sawtooth, I could have any kind of other signal that when it comes along and it breaches that 0 point line, I can flip my switch. So I can change any signal basically into a square. It might sound a bit of a crazy thing to do, but we've got, there's that rack extension, which is the LPCV, which basically allows you to do a ramp over 100 bars. It's a very, very slow playing signal. And I can take that really, really slow one, and rather than having it as a ramp going up, I can actually have it as a square. I find it more handy to sort of say to turn something on and then turn something off. So I can have a very, very slow running LFO, which I can then turn into a square, because that LFO doesn't have a square, it's just got a triangle and a sawtooth. So that's a way of converting that. So I have gone sidetracked, I've waffled. Be careful, focused. So yeah, so that's what this is doing. This is actually doing a countdown of the lengths. So once the lengths get down to a 0 or below 0, it sets this to true. However, a signal's not fired off to here to say, hey, you can move on to your next patch, because then that signal is actually coming and being controlled by this LFO, which is randomized up here. So basically, they've both got to say true to allow a signal through to say to you, hey, go and select your next phrase. So just to make sure, or to clarify, the length is going to come in. Even though this is switching between true and false because it's an LFO, nothing's going to happen. It doesn't care, because it's got to say, no, you've got to go and do your bit first. And in this particular case, I'm looking at a single length to make sure I've finished my whole length. Once I've finished my whole length, I can say, yep, I've finished my length. Then the randomization process really is going to say, right, am I true or false to move on? And obviously I've got some scaling stuff down here as well. I have this outside of the combinator rather in the combinator, because I'm pretty confident that I can definitely get rid of one of these, and I'm looking to get rid of this janitor as well, because I'm actually just doing a little bit of an offsetting. So I will be stripping this down and making this a lot more shorter as well. So it's just to get things up and running to start with. So I've really waffled enough. I've got this turned on. I'm going to turn this on, and I'm just going to let this play out. I won't play it through all 53 phrases, but you'll actually hopefully start to see things working. So I'll just say bye for now and let this go. And I've got to hit reset, turn it on, and theoretically it should go back to 0. It may not start instantly because it'd be based on this LFO of what's going on to that LFO, he says. So we've gone to 0 and we're starting. So these are changing, but you can actually see what was happening here now. So on pattern number 4, got a length of 1. A length of 1 really is 7/9. 7/9 is what I'm taking off. So we've got now a longer bar. Here it's counting down. And once this goes to true, we've got that. In fact, it went to true very quickly, and because this one was already set, it automatically went. But you could see these, oh great. So this is possible for this to go into a big minus number, and it's not an issue that it's going into a minus number. As soon as it goes minus, it's setting that. Obviously, with this particular LFO going forward, I will totally weight it. But you can see we've got a start of something. We've got a lot further to go yet though. I'm going to say bye again, aren't I? Oh well.